Howdy! This is your friendly neighborhood physics teacher here, and we're going to talk about metrics today. Woohoo! Yay, metrics! Okay. So this is your metric stairwell. Now you do have this PowerPoint on Schoology that you can go at your own pace. I'm going to go pretty fast just so we can get the gist. So this is the upper part of your metric conversion. So your base units, where it says base, is like your meters, your liters, your grams. It would be newtons, joules, any of those units that's just your base unit. These are prefixes. So giga, mega, kilo, heka, deca. And yes, you want to leave these spaces here. When we start putting numbers, you'll see why. So metric name, metric symbol. This is the lower part. Now, so again, lower part, base, metric, prefix, and metric symbol. And again, you'll want to leave those spaces there if you're writing it down. So as you go up the stairs, your decimal is going to go to the left. Kind of think about it. So if I go up, I have to move to the left to get to the staircase. If I'm moving down the staircase, I have to move my decimal to the right because I have to move my mouse to the right to touch the staircase. So for naming system, so for example, our GM would be a gigameter. Our mu L would be a microliter. So that's how it works. You have to have a base, and then you have any prefix. So let's do an example. So if we have a gigagram, and we're trying to get to a kilogram. So look at your exponent. So your gigagram has an exponent of 9. You always do the first exponent minus your second exponent. Your second exponent for kilo is 3. So you're literally going to do 9 minus 3, which gives you 6. That's telling you you're going to move 6. Now it's a positive number, so you're going to move it 6 to the right, which makes sense because I'm going down the staircase and I have to move to the right to get to the stairs. So you're going to do 6 jumps to the right. And I'm about to be in the way again. Let's take myself over here. Just a floating head. It's okay. So what you're going to see is 1, 2, 3, 4, 5, 6 jumps. That's where your decimal goes, and you fill in the jumps with zeros. So you get that many kilograms. Now that is considered standard form. In physics, we use scientific notation form. So that means scientific notation is you have to have the decimal with only one number in front of it. That's not a 0. So we have to move the decimal back 1, 2, 3, 4, 5, 6, 7 times. So we get 5.30. So you can see the difference. 5.3 times 10 to the 7. The reason we know it's positive is because we're going from a bigger number, this 50 million? 300,000? Sure. So we're going from a big number to a smaller number, the 5.03. We know that our exponent has to be positive. Let's do another one. So we're going to start from nanograms, and go to centigrams. So again, we're going to do -9 minus a -2. You always subtract them. And you get a -7. That's negative. It's just telling you you're moving to the left. Again, which makes sense. If we're going up, we're going to go up and then to the left. So we're going to do 7 jumps to the left. I never know where to put myself. Or just put times 10 to the negative 7 after the number. So like that. So if you don't like jumping, it's an easy way. Now, this is still considered standard form because it's not in scientific notation. The reason it's not in scientific notation is because we have 2 numbers in front of the decimal instead of 1. So we still have to move it over 1. And since we had 7, we moved it over 1. Why does that look? Oh, the decimal didn't get moved. Oh no, I'm so sorry. Fun PowerPoint thing. That should be 5.03, not 50. That's a mess up. Let's do a practice problem. I don't know where to stick myself. So Jessica is measuring 2 line segments. The first line segment is 30 centimeters long. The second line segment is 50 millimeters long. How long are the 2 line segments together? And we want our answer in kilometers. So the first thing we need to worry about is 30 centimeters. And we're trying to get it all to kilometers. So let's remember our exponents. If you look at your notes, your centimeters is a -2. Minus, always subtract, your kilometers, which is a 3. So -2 minus 3 gives you a -5. So the 2 ways. This negative is telling you that it's moving to the left, so you could just go ahead and jump 1, 2, 3, 4, 5. And you get 0.1233 kilometers if you want to do the jumping. Or remember, this is an exponent. So you could just do 30 times 10 to the -5. Either way works. And again, both of these, though, are in standard form. If you want to put it in scientific notation form, the decimal needs to be behind the 3. So there's only 1 number in front of it. So this one we would have to move. That one doesn't work. Let's do this one. 1, 2, 3, 4. So we have to move 4 times. We're going from a smaller number to a bigger number. The 3 is bigger. So going from a smaller number to the bigger number, it's going to be a negative exponent. Or here, we're going from a bigger number, 30, to a smaller number, 3, so it'll be a positive exponent. So you're just adding 1 to the mix. So our scientific notation form, the form we're actually looking for, would have been 3.0 times 10 to the -4. That is your scientific notation form. So that's 1. We also need to do the 500 millimeters. So our 500 millimeters, we're trying to get to kilometers. So our 500 millimeters, our millimeters is a -3. Always subtract. Kilometers is 3. So a -3 minus a 3 gives you a -6. So again, that negative is just telling you to the left. we can move it 1, 2, 3, 4, 5, 6 to the left. Or, if that's an exponent, you can just do 500 times 10 to the negative 6. To get it into scientific notation, you have to 1, 2, 3, 4. So that'll end up being negative 4. Or we can 1, 2. That ends up being a positive 2. And our answer is 5.0 times 10 to the negative 4. You can see how you get negative 4 either way. So we converted both of them to kilometers. Now we're seeing how long are the two segments together. After that, you just add the numbers together. And this is what basically all that is saying in words. Yeah, so if you do the ORs, that step 4 is not needed anymore. So there you go. I hope that helps. If you have any questions, please let me know. Yeah, hope you have a wonderful day. Remember, you're loved and appreciated. Bye.